Starting Chapter 15, Rules of Differentiation. Part of this is review, and maybe some of it's new. In Part A, we're going to talk about simple rules of differentiation. Differentiation is a process of finding a derivative or a gradient function. Okay, remember that from the previous unit. Given a function f of x, we obtain f dashed x by differentiation with, and then here we want to say with, and if you have a question about this, you could look at the book. I'm just getting ideas out of the book. With respect to the variable x. And what that means is we are going to assume that x is the domain variable or the horizontal axis when we're taking the derivative. Okay, and that'll become more clear when we start looking at graphs. Recall from the investigation or copy from the reading. By using the following rules, we can avoid the long work of finding derivatives by first principles. Remember, finding derivatives by first principles, you guys took like x plus h and you plugged it into the function, and then you took x and you plugged it into the function, and then you subtracted the two from each other, and then you divided by h, and then you took h and you made it approach 0 with a limit. And when you do that, then look, the denominator becomes 0, so that normally would make an infinite number, but you avoid it by cleverly arranging the numerator so that the h divides out. Okay, and then you find out that it doesn't become infinity. Okay, so the first thing we're going to do is we're going to say, what if the function is just a constant? And remember that if your function is a constant, that means it's a horizontal line. Basically like a function like this, y equals 2, so that's a horizontal line at height 2. If you have a horizontal line, what's the gradient of a horizontal line? Well, a flat horizontal line, the gradient is 0, so the derivative is also always 0. So we could put here just the rule is differentiation of a constant. There's not really a rule for that. It's too basic, I guess, to give a rule. And so now we have x to the n. If you can't read it, I'll write it bigger there. So this, you're going to use what we call the power rule, the most popular in calculus. And what you do is you take the n and you put it out front, and then you put the variable after it, and then you subtract 1 from the power. So you have nx to the n minus 1 is what you end up with. And then we have multiplication by a constant. It's not really a rule either. But remember, whenever you have a constant multiplied times a function, when you take the derivative, you just leave the constant there, and then you just take the derivative of the function. So I put u dashed x, and I just leave c out in front. And then I don't remember what the name of this one was. Something like differentiation of a sum or something like that. Okay, or maybe addition rule. I think it's called the addition rule. Okay, in the addition rule, you're taking the derivative of two things added together, and basically what you do is you take the derivative of each separately, and then you just add them together here. Okay, so those are the four basic rules. And then let's try some problems out here. Okay, so find f dash x, given that f of x is, and so they're just saying take the derivative. They're going to always give it to us in different language, so we get used to it. So the derivative of x cubed, using the power rule, is 3x squared. We take the 3, we put it out front, and then we subtract 1 from the power. So there's the first one. The next one is 3 times x cube root, and that looks kind of challenging, but if you rewrite it as 3x to the 1/3, because a cube root is the power 1/3, you can see that here it's just multiplication by a constant, and then here is just the power rule. Although it's not an integer, the power rule still works. So you just bring the 1/3 out front, and then you subtract 1 from the power, and you end up with this, which is, it simplifies to x to the negative 2/3. Okay? What about this one? This is just the addition rule. So we have 4 over 2x cubed minus, and then we have 6 times 2 is 12. Hopefully I'm not confusing you by doing too many things at once, but if you have negative 6x squared, you take the derivative, you're going to end up with 6 times 2x, so that's 12x to the first, right? And we can simplify that a little bit. Instead of 4 over 2, we could put 2x cubed minus 12x, for example. Okay. X cubed plus x minus 3 divided by x. Okay, now this looks pretty hard to do. You cannot just take the derivative of the top and leave it over this denominator, because there's a variable in the top and the bottom. So you need to simplify it so that it's something that we can use these simple rules to solve. First thing you're going to do is you're going to divide each thing by x. So you're going to have x cubed divided by x plus x divided by x minus 3 divided by x. And now you have 3 different terms. You can use the addition rule. So x cubed divided by x simplifies to x squared. X divided by x simplifies to 1. And negative 3 over x stays negative 3 over x. If you take the derivative of this, you're going to get 2x plus, and 1, the derivative of 1 is just 0, right? Because it's a constant. And then you take negative 3 over x. What is the derivative of negative 3 over x? Well, remember, negative 3 over x is the same thing as negative 3x to the negative first. So really, you just need to do the power rule. There we go. Okay, not so bad. What about c? So this would be 7 times 2x, so it would be 14x. And then here, this would be 4, the derivative of 4 would just be 0. The derivative of negative 2x squared would be 2 times negative 2, negative 4x. Try never to write an equal sign here. If you need to put something, put like an arrow to show that something's changing, but don't put an equal sign because these are obviously not equal to each other. One is a derivative and one is the original function. This is similar to m, where you just need to divide each term by the denominator. So we have 2x over x squared minus 3 over x squared, and we're just going to take the derivative separately of those. So it would be 2x to the negative first minus 3x to the negative second. And if we take the derivative of these, it would be negative 2x to the negative second plus 6x to the negative third. Okay? And then like this last one here, 2x minus 1 quantity squared. We don't know how to do this yet. You can't just simply treat this as a big giant power rule. It's a little bit more complicated than that. We'll discover that in the next section. So what we can do is we can multiply everything out. So we're going to multiply and make it into a quadratic. So 2x quantity squared minus 2x plus 1. So that would be 4x squared minus 4x plus 1. If you take the derivative of this, you get 8x minus 4. Okay? Alright. Last one on this page. So it says find dy dx for these functions, and that just means take the derivative. Just another way of saying take the derivative. So let's see. The derivative of 2.5x cubed would be 2.5 times 3, x squared, which would just be 7.5x squared. The derivative of negative 1.4x squared would be negative 1.4 times 2 times x to the first. So that would be negative 2.8x, right? Do you see how that works? It would be negative 1.4 times 2 times x to the first, right? So that would just become that. The derivative of negative 1.3 is just a constant, so the derivative of that part is 0. So we're just left with that. This one, we need to simplify it first so that it's, let's see, we'll have 1/5, and then we'll have x to the negative second. Now we just use the power rule. So it'd be 1/5, negative 2, x to the negative third, because we go down one more level, we subtract 1 off of that. So that's negative 2/5, x to the negative third would be the answer. And then for this one, it's easier if we just simplify it. So we just multiply 10 times each of the terms, and we get 10x plus 10. Now we just use the power rule, 10x, the derivative is 10, derivative of 10 is 0, so we just end up with 10 there. Okay? And that was the first page.